Now that we can manipulate syntax trees, let's get a bunch of them. Instead of typing out Python code that constructs each tree, we'd like to read them from a file. And that file was created by the project that annotated a lot of English sentences with their syntactic analysis. Here's some tips on how to read in a file, turn it into strings, turn those strings into lists, and make progress in terms of manipulating the data after you've done that. Some files are plain text, and so they can be read into Python, either as one string that contains the whole contents of the file, by opening a string that represents a path to the file, as well as adding the .read method. Or you can have a list of strings, each containing one line of the file, by opening the file and reading its lines, which is what we're going to use in this demonstration. Once you've read the lines, you want to figure out what's in those lines. And here are some useful string methods for processing the contents of a file that is a plain text file with structured data within it, representing trees. .strip is a string method that returns a string without any white space, such as spaces and tabs, etc., on the end, and this helps get rid of indentation. So if you have hello and you strip off the spaces at the beginning and end, you're left with just the letters and no spaces. Split returns a list of strings that were separated by a white space in the string. So if I split hi there into its words, I get hi and there. Notice there were two spaces here. That's okay. It still splits it up into hi and there. A third useful method is the replace method on a string, which takes in two arguments and returns a string with all instances of the substring A replaced by the string B. The way we'll use this in this project is to create white space around the parentheses that we need to treat as separate words. So for example, if we had 2 plus 2 and we wanted to create space around the plus, I could replace all the pluses with space plus space. Now I have 2 space plus space 2. If I split that, I get 3 different elements in the resulting list, 2 plus and 2. Whereas if I had split the original version, I'd just get one element that had the 2 plus 2 all together. Let's try this out, and you'll see why these are useful. We're going to be reading data from a file that is distributed as part of a data set called the child's tree bank, which is utterances that occurred in conversations with children that were then later annotated with a syntactic analysis. And the contents of that file looks like this. It's longer. It's got a bunch of examples, but here's 2 of them that we've been talking about so far. And you can see how the tree structure is being represented using parentheses. Open parenthesis is the beginning of a tree. Here's the root label. Here's the beginning of a branch and its label. And each parenthesis is balanced. So this verb phrase doesn't end until way down here after is that a big bug or a little bug. Whereas this noun phrase, a little bug, ends here. And a big bug ends there. Now within the file, oftentimes a single utterance is split across multiple lines. So here's a function that takes in those lines and constructs a list that's just one element per utterance. And that element is itself a list full of strings, strings like open parenthesis, root, open parenthesis, SQ. So in this doc test, I read all the trees from the lines of this example, where notice that I've written down the example and then split it into lines. And then, for the results, I'm not actually printing out the whole result. Instead, I'm just printing out the first 20 elements of each result, and then some dots at the end. One thing I'm not sure I've explained yet is what the join method does on a string, but I can demonstrate that quite quickly. If you have a list of words, such as a little bug, then you can join them together using a space to get one string, a little bug, where the elements of the original list are separated by spaces. And if you really wanted them separated by pluses instead, you could do that. All right, so we begin with examples. There's 2 of them, 1, 2. but the examples list is much longer because it's a bunch of lines. So the approach we'll take is to use append and extend to build up a list of all of the words and parentheses for each example. When we get to the end of an example, which we'll know because we've matched up all the parentheses, we'll put that in a list of all the trees that we've read from the lines. Let's get started. We'll start with an empty list of trees, an empty list of tokens. A token is either a word or a tag or a parenthesis, so one of the elements of the list that represents a whole example. Now we go through all the lines. If the line is not blank, it can be expressed with if line.strip. Stripping away the white space of a line that has only white space leaves you with an empty string, which is a false value. But stripping away the white space and leaving some letters and symbols behind leaves you a true value, and so we need to include all of the contents of that line in the current list of tokens. Now, in order to put the parenthesis as its own element next to root, we can't just split immediately. Instead, we have to take that line and replace all of the parentheses with a version that has a space around it. Let's do the same thing with closing parentheses. So what this would do is, say we were working with examples 1, which looks like that, replacing open parenthesis with one with spaces around it would separate these out, which is nice because then if I take this result and split it, I'll have the parenthesis separate from the root, separate from the parenthesis, separate from the next tag. So that gives us the next step, which is to split. Now I have a list of elements like this. We'll call these tokens. And we want to put them onto the list of the tokens for the current example. Now, how do you take a list and add all of its elements to the end of an existing list? That's what extend does for you. Now, it might be the case that this line is the last line in an example. And if that's the case, we need to stop building up tokens and put the current tokens into the list of trees. I can count the number of open parentheses. I can also count the number of closed parentheses. If those are equal, then I've reached the end of the example. The original open parenthesis has now been balanced. So if that's the case, what I'd like to do is take all the tokens and put them into trees. But now I'm going to start a new example, so I'll set tokens equal to an empty list so that I can start populating it with whatever's the next line in lines. And that's it. When I go through all the lines, now it's time to return trees. So let's see what we've achieved. If we read trees of our examples, we'll call those T's for trees. How many of them are there? There are 2. And what's the element at index 1? It's a representation of this very example that we've been talking about all along, a little bug. Open parenthesis root, open parenthesis frag, open parenthesis noun phrase, open parenthesis determiner, and finally we get to the word a. Whereas tree 0 is much longer, right? Somewhere within here, we can see the words, is that a big bug or a little bug? And if we count the number of open parentheses, there are 17, and there are 17 closing parentheses, meaning that this is a well-nested example. Now, read trees works for the 2 lines that we have in this file, but it also works for all the lines that exist in the dataset. So let's get all of those by just calling all trees. I've put in the path on my computer to the parses, the syntactic trees, for all of these sentences, so I don't actually need to pass that in here. It'll just use the default value. Now we can see how many different examples we have to work with is 35,000. And if we look at the first one, it's a sentence that says, "This is a book." And there are short examples, like someone just said "and" once. And there are long examples, like someone said, well, I won't go through the whole thing, but I see a few words here. are you going to blah, 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 blah. So now we can read in the data.